For practice number 1, we're trying to find the area between x squared and negative x. So I'm just going to sketch a really quick graph of this. So here is x squared, and then I have negative x comes like this. So I have this really tiny region that's difficult for us to see when we're graphing it by hand, but it's right here, okay? So I need to figure out where these intersection points are on this graph. So I'm just going to set these two things equal to each other. So x squared equals negative x. That gives me x squared plus x equals 0. Factor out that x. I'm going to get x equals 0 and x equals negative 1. So I now know what my bounds are. So I just need to now integrate, going from negative 1 to 0, looking at whichever function is on top. So that's negative x. And subtracting the lower one, so that's x squared. And I'm integrating from for dx here. So now we just have to evaluate everything. Plug in all this stuff, and I'm pretty sure we just get a lovely 1/6 units squared. For number 2, I used my calculator to help me graph it and find the intersections, even though the intersections ended up being pretty nice numbers. So I'm just going to approximate that. That's our x to the third. I have the other equation that comes down here. So I'm looking for this region right there. So when I go to figure out these intersections, so again, I just used the calculator. I got that was at an x value of negative 1 and an x value of 2. So I'm going to integrate from negative 1 to 2. The function on top is x to the third. The function on bottom is the 3x squared minus 4. I need parentheses when I subtract it, or this is not going to work out very well for me. And from here, it's just finding the integral, everything that you already know how to do. That's a 2. Plug it all in, and we're going to get 27/4 units squared. Okay, 3. They gave us a lot of information here. We have y equals e to the x, so that's that guy right there. We have this 1 over x, that's coming down like this, and then they're asking us to evaluate this from the x values of 1 to 2. So we end up with this region that's kind of in here, I believe. So let's go about setting this up. So I'm going to have the integral from 1 to 2. I need to know which one is on top. Oh, I drew this wrong. My bad. Let me fix that. That was terrible. This one right here goes like this. It has a horizontal asymptote. My bad. That was terrible. All right. So now we can actually see the region. I was wondering why things looked kind of weird, and I don't think the intersection is at that point. So I actually think that this is the region we're looking at. Sorry about that. So the top one is going to be e to the x. The bottom one is the 1 over x, doing that. So we have e to the x minus ln x from 1 to 2. Plug all of this into our calculator. I'm going to get 3.978 units squared. So first impression with 4 is that we're going to be integrating this one with respect to y, mainly because of the way that they gave me that first equation there. So I'm actually just going to immediately solve this one for x as well. So this is a sideways parabola, opening in the positive directions, and then I have this guy right here. It's kind of going like this. Again, not really drawn to scale. So this is a prime candidate for us to integrate using the y equations. It would be really difficult for us to do this with x because we'd have to figure out what was going on like in different places. It just would not be an ideal situation. So what I like to do is kind of draw arrows or little lines that kind of show me which one's on bottom and which one's on top. So I always figure out which axis I'm kind of integrating from. So if I'm doing it with respect to y, I'm coming from here, and then I draw a little arrow up, and then I can see which one's the big one and which one's the small one. That helps me figure out what's going on. So I'm going to end up with the integral from this top part, 1 minus y, minus the 2y squared dy. And I need to know what my bounds are, so I'm just going to set these two equations equal to each other. So I have 2y squared equals 1 minus y. So that's 2y squared plus y minus 1 equals 0. I ran out of room up there. I'm just going to write it way down. No, fine. I'll write it over here. I'm going to have 2y and y. And let's see. I need the middle term to be positive, so that's going to be here and here. So I'm going to get y equals 1/2 and negative 1. So negative 1 to 1/2. And then again, if you have a calculator, use your calculator. If you don't, then we just do it the old school way. Either way, you end up with 9/8 units squared. 5 is another one that's set up for us to integrate with respect to y when we're doing this. So let's just sketch a quick graph of this. This right here is going to be a sideways parabola that has been shifted sideways, -2, so it's going to be back here. This right here is actually y equals ln of x, so ln of x kind of comes like this. And then we're looking at this from -1 to 1 for our y equation. So that's going to be here and here. So we end up with this kind of region in here, okay? So since we're doing this with respect to y, what I need to figure out is which one is more to the right, okay? So that's going to be this one followed by that one. So if I'm going in this direction. So let's integrate. It's going to go from -1 to 1. I'm looking at the y values here, and I'm doing the top equation, which is e to the y, minus the bottom equations. Make sure you put those parentheses there. That's really important. And I'm integrating with respect to dy. So if you have your calculator, use your calculator. If you don't, do it the old school way like I'm doing right now. Plug everything in. I am cheating and using the calculator to figure out what that is, but I end up with 5.684 units squared. So for 6, I used the calculator to help me graph what this looked like. So that's what the f of x equation looks like, and the g of x equation is just a, let's see, it kind of goes like, I don't know, that's not probably perfect, but it kind of looks like this. So I need to know what all of these intersections are, and then I'm also going to be integrating this over 2 pieces. So I'm going to have this region over here and this region over here. So first let's just set these two things equal to each other to find the bounds. So I'm going to immediately be able to cross off these x squareds, and then I'm going to end up with 3x to the third minus 12x equals 0. So let's pull out a 3x. And let's see, we're going to get x equals 0 and x equals plus or minus 2. So now I know what all of these bounds are. So I now know that I'm going to go from -2 to 0 for a with the green equation minus the blue equation. So that's going to be 3x to the third minus x squared minus 10x minus -x squared plus 2x dx. For b, that's going from 0 to 2. And it's going to be the opposite of that, so I'm going to have -x squared plus 2x minus 3x to the third minus x squared minus 10x. And this is definitely a great one for us to just use the calculator for. So this part was 12, this part was also 12. So when I add these two together, I get 24 units squared. Is the answer. That's the area bound between these two curves. Okay, for 7, let's just sketch a quick graph of it. We have x plus 2, that kind of goes like that. We have a square root of 4 minus x, so that's going to start at 4 going in the negative direction, so it kind of goes like this. And we're also bound between the x-axis. Okay, so that gives us our region is bound between these guys. So if I were to do this with x, I would have to have a cut point right here. So I'm not going to use x, I'm going to instead use y, because if I use y, then I have the same function on top and bottom all the way through. So I'm going to end up using y, so that means I need to solve each one of these for x equals. So this is going to be x equals y minus 2. This one I'm going to square everything, that gets rid of that, and then I'll end up with x equals 4 minus y squared. I need to know where this intersection is. I know that this is at y equals 0, but I don't know what that one is, so I'm just going to set these equal to each other and try to solve this. So I'm pretty sure I get y squared plus y minus 6 equals 0, so that's going to be y plus 3, y minus 2, so I'm going to get y equals -3 and y equals positive 2. I'm going to throw out that -3 because it doesn't exist down here. And I'm going to be integrating this from 0 to 2 with this function right here on top. So that is the 4 minus y squared, so 4 minus y squared. And I subtract the bottom function, which is y minus 2. Don't forget the parentheses. Okay, if you have a calculator, use it. If you don't, do it the old school way, and we get 22/3 units squared.